All right, guys. So, welcome back again to my channel. We are on problem 2 now of Project Euler, and this is what it states. Each new term in the Fibonacci sequence is generated by adding the previous two terms. Yeah, that's the Fibonacci sequence. So, by starting with 1 and 2, the first 10 terms will be that. So, 1 plus 2, 3, 2 plus 3, 5, 5 plus 8, 13. 8 plus 13, 21, and so on, right? So they say by considering the terms in the Fibonacci sequence whose values do not exceed 4 million. So we don't want the terms which values exceed 4 million. Then they say we should find the sum of the even value. So all the values that are divisible by 2, right? Even valued terms. So that is the exercise. All right. So I went ahead of myself here so that we don't waste time like the last video to find the answer. So this is the final answer right here. All right. So let's go ahead and write the function that is supposed to execute that. And the function will be similar to this multiples 3, 5 that we just did. All right. So we'll just say function let's say sum even fib. All right, so to say sum of even numbers in the Fibonacci sequence. All right, and I will say n, and n is supposed to be the limiting number. All right, so in this case n is 4 million. They say the numbers should not exceed 4 million, so it should be all the numbers less than 4 million. Right, so MATLAB already has a function that enables me to generate the Fibonacci sequence. Okay, so but we will not use that function. Okay, we won't. Well, we'll assume that that function doesn't exist. So what does it mean? It means we need to first of all create a vector, right, that is supposed to have all of those numbers, all of the Fibonacci numbers from 0 right up to 4 million or so. So for us to do that, I'll initialize, as the problem says, a vector that goes 1, 2, right? 1, comma 2. And we'll increment this vector progressively in a loop, okay, in such a way that the final result does not exceed n, right? N, which is supposed to be 4 million in this case. So to do that, I'll use a while loop. I'll just say while v of n, right? V of n is supposed to be the last number that we just added to this vector, right? So while v of n is less than, all right, it's strictly less than n, okay, which in our case will be 4 million. And what do we want to do? We want to say v of n plus 1. So the new term in the v vector should be equal to v of n, or should we say sum of v, what can we say here? Let's not use complex stuff. Let's just index. All right, so should be equals to v of n plus v of n minus 1, right? So this will be the last two terms. All right, so let me take a practical example of what will happen here. So right now we are at 1, 2. Okay, so we are saying that v of n plus 1, so n plus 1 will add a third term here, and the value of that third term should be equals to v of n. So the current v of n here is what? Is 2, and then v of n minus 1 is 1. So it will be the sum of 2 plus 1, which will give us 3 at the position n plus 1, right? And then when it goes and comes up, it checks that 3 is less than n, which is less than 4 million, and then it comes back here to create a fourth term, which will be equal to 3 now, right, plus 2, and so on and so forth, right? So at the end of this loop, I should have my Fibonacci sequence. So here they should be telling me that it's changing loop on every single line. So what I will do is, let me just isolate that because I like my button here to be green. Show myself a written clean code. All right, so I have my Fibonacci sequence now. All right, so what will be my final answer? Z, that is supposed to be the sum of all of the even number. Well, Z will simply have to be sum of I will have to index V, right, and say all of the terms in V whose remainder when divided by 2, right? This is the remainder when divided by 2. Whose remainder when divided by 2 is equal to 0, okay? Their position should be taken into consideration here, and it is those positions of V that we are interested in to sum, okay? And the answer should be stored in Z, as simple as that. All right? So let's just save that. Save, and let's apply that with the 4 million. Okay, so CLC, so some even fib of 4 million. What does that give us? 4 million is something 4 times 10 to the power 6, right? To the power 6. And what's the answer? 461. So let me just shift this a little bit. 4613732. Perfect. Okay, so challenge 2 succeeded. All right, so see you guys in the next video for challenge 3. This is very, very interesting.